In my opinion, if aliens are here, I suspect the newspapers would be full of the story.
There was a very famous flare in the radio signal, that was given the name the wow signal.
On August 15, 1977, at 11:16 p.m. Eastern Time, a radio telescope called Big Ear at Ohio State University picks up something that should not exist. A burst of narrowband electromagnetic radiation at 1420 megahertz, the precise frequency at which hydrogen, the most abundant element in the universe, naturally resonates. The signal lasts 72 seconds. It is 30 times louder than the background noise of deep space. It comes from the direction of the constellation Sagittarius, roughly 120 light-years away. And then it vanishes completely, as if someone turned it on, broadcast for exactly 72 seconds, and turned it off. 3 days later, astronomer Jerry Ehman is reviewing the printout from the telescope's data recorder. Big Ear does not record audio. It records signal intensity as a sequence of numbers and letters on continuous feed paper. When Ehman sees the sequence 6EQJ5, a spike so intense it maxes out the telescope's measurement scale, he picks up a red pen and circles the sequence. In the margin, he writes one word, wow. That word becomes the name of the signal, the wow signal, and for 49 years, it has been the strongest candidate for an extraterrestrial communication ever detected by human technology. It has never been explained, it has never been repeated, it has never been debunked. Every natural explanation, comets, satellite interference, terrestrial radio leakage, equipment malfunction, has been proposed, tested, and found insufficient. And then, in late 2025, an AI trained on every known radio signal pattern in the electromagnetic spectrum did something no human astronomer could do. It processed the original 1977 data alongside 49 years of subsequent observations of the same region of sky and found a pattern that had been hiding in the noise all along. The wow signal did not come once, it came multiple times, but at intervals and intensities that only a machine could detect. What the AI decoded in that pattern has left the scientific community in a state of controlled panic. To understand what the AI found, you first need to understand why the wow signal has haunted astronomers for half a century. And to do that, you need to understand the telescope that heard it and the man who found it. Big Ear was not glamorous. It was not Arecibo or the Very Large Array or any of the iconic radio telescopes you have seen in movies. It was a flat, ground-level antenna the size of 3 football fields built in a field outside Delaware, Ohio, in 1963 as part of Ohio State University's radio observatory. It looked like a parking lot with a metal fence. It cost a fraction of what modern telescopes cost. And from 1973 to 1995, it was used for one of the most ambitious scientific programs ever attempted. A systematic survey of the sky at the hydrogen frequency, searching for signals that could not be explained by natural sources. The program was called the Ohio State University SETI survey. It was in every sense the first serious sustained effort to detect extraterrestrial intelligence through radio astronomy. Big Ear was a meridian transit telescope. It could not move or track objects across the sky. It pointed straight up and relied on the Earth's rotation to sweep its beam from east to west. Each point in the sky passed through the beam once per day for exactly 72 seconds. If a signal came from a fixed point in space, it would appear for 72 seconds, peak in intensity as it crossed the center of the beam, and then fade as the Earth rotated past it. The signal would trace a characteristic bell curve on the data recorder, rising, peaking, and falling over those 72 seconds. That is exactly the shape the wow signal produced, perfectly. Jerry Ehman was a volunteer astronomer working with the SETI survey. He was not famous. He was not on a tenure track. He was an electrical engineer and part-time professor who donated his time to reviewing the telescope's data printouts, long rolls of continuous feed paper covered in columns of numbers and letters that represented signal intensity at different frequencies. Most of the data was noise, background radiation, interference from satellites. Ehman had reviewed thousands of feet of printout without finding anything unusual. On August 18, 1977, 3 days after the signal had been received, Ehman was sitting at his kitchen table going through the latest printout. When he reached the sequence 6EQJ5, his eyes stopped. The numbers represented signal intensity on a scale where 1 was baseline noise and letters, above 9 continued the scale, A for 10, B for 11, and so on. U represents 30. The sequence peaked at U, 30 times the background noise level, and then fell symmetrically, exactly matching the profile of a point source signal crossing the beam. Ehman grabbed a red pen. He circled the sequence. And in the margin, almost as a reflex, he wrote, wow. He later said he wished he had written something more scientific. But the word stuck, and it became the name for the most famous unexplained signal in the history of astronomy. The frequency matters. 1420 megahertz is not a random number. It is the emission frequency of neutral hydrogen. The hydrogen line, also called the H1 line or the 21 centimeter line, hydrogen is the most common element in the universe. It constitutes roughly 75% of all normal matter. Every star, every nebula, every galaxy emits radiation at this frequency as hydrogen atoms transition between energy states. In 1959, Physicists Philip Morrison and Giuseppe Cocconi published a landmark paper in Nature arguing that 420 megahertz would be the logical frequency for interstellar communication. Any technologically advanced civilization would know about hydrogen, would know about the 21-centimeter line, and would expect other civilizations to be monitoring it. It is the universal channel, the cosmic commons, the one frequency every radio astronomer in the galaxy would check first. The wow signal came in at exactly that frequency, not approximately. Exactly. The duration matters, 72 seconds. Precisely the window that a point source would produce in Big Ear's fixed beam, not 60 seconds, which would suggest a closer or moving source, not 90 seconds, which would suggest a diffuse source. Exactly 72. Consistent with something far away at a fixed point in space, broadcasting continuously. The intensity matters. A signal-to-noise ratio of approximately 30 is extraordinary. Natural astronomical radio sources, even powerful ones like pulsars and quasars, rarely exceed a ratio of 2 or 3 in narrowband observations. A ratio of 30 means the signal was either produced by an extraordinarily powerful natural mechanism that has never been observed before or since, or by a focused, directed transmission from something that specifically wanted to be heard across interstellar distances. And the direction matters. The signal came from the constellation Sagittarius, from a region of sky near the star group Pi-Sagittarii, roughly 120 light-years from Earth. There are no known pulsars, quasars, masers, or other energetic astronomical objects in that exact patch of sky that could explain the signal. The region has been surveyed extensively. It is unremarkable, an ordinary patch of sky with ordinary background stars. And yet, on one night in August 1977, something in that ordinary patch of sky screamed at the hydrogen frequency 30 times louder than the silence around it. For 49 years, every attempt to detect the signal again has failed. Over 100 follow-up observations have been conducted with radio telescopes far more powerful than Big Ear, including the Very Large Array in New Mexico, the Green Bank Telescope in West Virginia, and the Allen Telescope Array in California. None have detected anything at the same frequency from the same location. The signal appeared once, spoke for 72 seconds, and went silent. In 2016, astronomer Antonio Paris proposed that the signal was produced by hydrogen emission from the comet, specifically comets 266P Christensen or 335P Gibbs that were in the signal's region of sky in 1977 but had not yet been discovered. The hypothesis generated headlines, but it was systematically dismantled by other astronomers who pointed out that comets produce diffuse, broadband emission, not the tight narrowband signal that Big Ear recorded. The comet hypothesis was dead within a year. The wow signal remained unexplained, the ghost in the data, the one scream in 49 years of listening, until the AI started listening differently. In 2022, amateur astronomer Alberto Caballero published a paper identifying a sun-like star in the wow. Signal's region of origin 2MSS 1928-1982-2640123 that matches the type of star most likely to host habitable planets. The star is roughly the same temperature, luminosity, and age as our sun. It is the kind of star around which rocky, water-bearing planets could exist. The discovery did not prove anything, but it narrowed the field. If the signal came from an intelligent source, this star was the most plausible candidate for its origin. In 2023, a team of researchers published an analysis suggesting that the signal could have been produced by a cloud of hydrogen stimulated by a maser effect, a natural amplification process, similar to a laser but operating at microwave frequencies. This would explain the narrowband frequency and the intensity without requiring an artificial source. The paper was taken seriously, but not universally accepted. Critics pointed out that the maser hypothesis requires very specific conditions that have not been observed in the signal's region of sky, and then came the AI. In late 2025, a team at a university research lab, which has requested anonymity until peer review is complete, decided to do something that no one had attempted in the 48-year history of the WOW signal. Instead of pointing a telescope at the sky and waiting for the signal to repeat, they went backward. They gathered every radio observation of the WOW signal's region of sky that had been recorded by any telescope anywhere in the world since 1977. Every survey, every targeted observation, every deep field scan that happened to include that patch of Sagittarius in its field of view. Thousands of hours of data from dozens of instruments across 4 decades. Then they trained a deep learning model on the complete catalog of known radio signals in the electromagnetic spectrum. Pulsars, quasars, masers, fast radio bursts, magnetars, satellite transmissions, terrestrial radio frequency interference from cell towers and microwave ovens and aircraft, radar, atmospheric phenomena from lightning and aurora, and solar emissions from flares and coronal mass ejections. Every type of radio signal that exists, natural or artificial, was fed into the model. The AI learned what every type of known signal looks like, its frequency profile, its temporal pattern, its intensity curve, its spectral width, its polarization characteristics. After training, the model could classify any radio signal with 99.7% accuracy as either natural, artificial terrestrial, or unknown. They fed it the WOW signal data. The AI classified it as unknown, not natural, not artificial terrestrial. Unknown, a category the model assigns to signals that do not match any known pattern in its training dataset. The statistical confidence was 98.2%. But that was only the beginning. The team then did something that had never been attempted before. They fed the AI not just the original 1977 data, but the complete dataset of every radio observation of the WOW signals region of sky from 1977 to 2025, thousands of hours of recorded data from dozens of telescopes around the world. The AI was asked to search for any recurrence of the signal, no matter how faint, at any frequency within the hydrogen band. What it found sent a shockwave through the research group. The AI identified 7 instances of anomalous narrowband emission from the same region of sky spread across a 48-year period. None were anywhere near the intensity of the original 1977 signal. Most were barely above the noise floor, so faint that no human astronomer reviewing the data would have flagged them. But the AI, processing millions of data points simultaneously and looking for statistical correlations that the human brain cannot perceive, identified them as part of a pattern. The intervals between the 7 detections are not random. They follow a mathematical progression that the AI identified as consistent with a base frequency modulation pattern, a type of encoding used in information theory to embed data within a carrier signal. The research team is being extremely cautious in their public statements. They have not claimed the signal is extraterrestrial. They have said only that the pattern is inconsistent with any known natural phenomenon and warrants further investigation with dedicated observation time. But privately, according to sources familiar with the research, the team has described what the AI found as the most significant anomaly in the history of SETI. There is one more detail that has generated intense debate, and it is the most controversial claim associated with the WOW signal analysis. Multiple independent researchers working separately have noted that the frequency of the WOW signal, 1420, 4056 megahertz, has a mathematical relationship to fundamental constants that is difficult to dismiss as coincidence. Specifically, when you multiply the hydrogen emission frequency, 1420405.751 megahertz, by the mathematical constant pi, 3.14159.265, you get a frequency of approximately 4462.336 megahertz. Some researchers have noted that this frequency falls within a range that has been proposed as an optimal water hole frequency for interstellar communication, a quiet band between the hydrogen and hydroxyl emission lines where radio interference is minimal and any technologically advanced civilization would know to listen. The argument is this: if an intelligent civilization wanted to signal its presence to another civilization that understands both hydrogen physics and mathematics, broadcasting at the hydrogen frequency would be step 1. Embedding a pi-based modulation pattern in the signal would be step 2, a mathematical watermark that says this is not random, this is from someone who knows mathematics. The AI analysis of the 7 recurrence patterns reportedly found that the intervals between detections are mathematically consistent with a Pi-derived timing sequence. If confirmed, this would mean the signal is not just unusual, it is structured in a way that encodes a mathematical constant that is universal to any civilization that understands geometry. The skeptics' response is straightforward: pattern seeking in noise. The human brain and artificial neural networks are extraordinarily good at finding patterns, even in random data. Given enough observations and enough mathematical constants to test against, you can find a correlation with anything. Pi appears everywhere in physics and mathematics. Finding it in the timing of faint radio signals could be a statistical artifact, not evidence of intelligence. The counter-argument is that the AI was not searching for pi. It was searching for any mathematical structure in the timing intervals. Pi emerged from the data unprompted. The model was not told to look for it. It found it on its own. That does not prove extraterrestrial intelligence. It proves that the signal contains mathematical structure. Whether that structure was placed there intentionally or is a product of natural processes that we do not yet understand is the question that the next generation, the question of whether we are alone in the universe, is the oldest question humanity has ever asked. Every culture, every civilization, every religion has grappled with it. And for the first time in history, we have tools, radio telescopes, AI pattern recognition, and mathematical analysis that are capable of detecting an answer if one exists. To understand why the WOW signal matters so much, you need to understand the paradox that has haunted astrophysics for 75 years. In 1961, astronomer Frank Drake wrote an equation, now called the Drake equation, that estimates the number of technologically advanced civilizations in our galaxy. The equation multiplies a series of factors: the rate of star formation, the fraction of stars with planets, the fraction of planets that develop life, the fraction of life that becomes intelligent, and so on. Depending on which estimates you use for each factor, the Drake equation produces answers ranging from "we are alone" to "there should be millions of civilizations in the Milky Way." The problem is that if the optimistic estimates are even remotely correct, if there are thousands or millions of civilizations in our galaxy, we should have detected their signals by now. We have been listening for over 60 years with increasingly powerful equipment. The galaxy is 13.6 billion years old. Our civilization has had radio for barely a century. If other civilizations developed radio technology even a few thousand years before us, their signals should be everywhere. The galaxy should be noisy. It is silent. This contradiction is called the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked the question at lunch in 1950. Where is everybody? The wow! Signal has always been the tantalizing almost answer to Fermi's question. A signal that looks artificial but was never repeated. A signal that came from the right frequency, the right direction, and the right intensity to be an interstellar communication, but appeared only once, making it impossible to verify. Scientists cannot claim detection based on a single unrepeated event. In SETI, the gold standard is repeatability. Detect it, confirm it, detect it again. One signal, no matter how strong, is not enough. What the AI has potentially changed is the appeared only once part. If the 7 faint recurrences are real, if they are not noise artifacts or processing errors or coincidental natural emissions, then the wow signal is not a one-time event. It is a repeating signal with a pattern that encodes mathematical structure, a pattern that has been broadcasting from the same region of sky for at least 48 years. And 48 years on a cosmic timescale is nothing. Our galaxy is 13.6 billion years old. Our species has existed for 300,000 years. We have had radio for 130 years. 48 years of detections is not even a blink in cosmic terms. If a civilization were broadcasting a beacon, a deliberate long-term signal designed to be detected by any emerging technological species in its neighborhood, 48 years would barely register. They might have been broadcasting for thousands of years, or millions. We just were not listening until 1977. And we were not listening well enough with sensitive enough equipment and smart enough analysis tools until the AI started processing the data in 2025. There is another possibility that the AI analysis raises, one that is more unsettling than either the natural phenomenon or alien beacon explanations. What if the signal is not a beacon at all? What if it isn't designed to be heard? What if it is leakage, the electromagnetic equivalent of light pollution, produced by a civilization going about its business without any intention of contacting us? We broadcast radio waves constantly, television, radar, satellite communications, and those signals leak into space at the speed of light. Any civilization within 130 light years of Earth could, in theory, detect our leaked signals. What if the wow signal is someone else's leaked transmission that happened to sweep past our telescope at the exact moment we were pointing at the right patch of sky? If that is the case, the signal is not a message, it is evidence. Evidence that someone is out there doing something that produces narrowband radio emission at the hydrogen frequency in a pattern that encodes mathematical structure from a region of sky that contains a sun-like star. Not a greeting, not a handshake, just the noise of someone else existing. The research team has applied for dedicated observation time on multiple radio telescopes to conduct continuous monitoring of the signal's origin point. If the AI's prediction is correct, the next recurrence of the faint signal should occur within a calculable window based on the intervals between the previous 7 detections. If it appears on schedule at the predicted time, at the predicted intensity, from the predicted location, the probability of a natural explanation drops to near zero. That would not prove extraterrestrial intelligence, but it would prove that something at a fixed point 120 light years away is producing structured, repeating, non-natural radio emission at the one frequency the entire galaxy knows to listen to. That observation has not yet been conducted. The results are pending, the telescope time has been requested, and the scientific community is holding its breath. On August 15, 1977, a radio telescope in a field in Ohio heard something, a 72-second whisper from the direction of Sagittarius, a single burst from the void, spoken in the language of hydrogen at a volume 30 times louder than the silence around it. It lasted just over a minute, and then it stopped, as if someone or something had said one word and then waited to see if anyone was listening. Jerry Ehman circled it in red ink and wrote, "Wow." He was an engineer at a kitchen table. He did not know he was holding the most famous unexplained signal in the history of science. He did not know that his one-word annotation would outlive him, outlive the telescope, and outlive the university program that recorded it. Big Ear was demolished in 1998 to make room for a golf course. The telescope that might have heard an extraterrestrial broadcast was bulldozed to build a driving range. The printout with Ehman's red circle is now in the Ohio History Connection archives. The paper is yellowing, the ink is fading, but the data is preserved digitally, and that data is what the AI went back to. For 49 years after the signal, we've pointed every dish we had at that same patch of sky and heard nothing. We concluded it was a fluke, an anomaly, a statistical ghost. We moved on. We had to. Science requires reproducibility, and the wow signal refused to reproduce. It came once, it said its piece, and it left. But the AI did not move on. The AI does not get frustrated. It does not get bored. It does not conclude that 49 years of silence means the first detection was a mistake. It went back through 48 years of data, millions of hours of recorded silence from dozens of telescopes spread across 4 continents and spanning nearly half a century of observation, and it listened. Not for the loud scream that Ehman heard, for something quieter, something that a human ear or a human mind reviewing data printouts at a kitchen table would never catch. And in that ocean of silence, in the static hiss of cosmic background radiation that sounds like nothing to anyone who is not a machine built to hear patterns, the AI found something we missed. 7 whispers, 7 faint narrowband emissions from the same region of sky, barely above the noise floor, invisible to the human astronomers who recorded them, spread across 48 years, following a mathematical pattern that should not exist in nature. Pi. 3. 44159, the ratio of a circle's circumference to its diameter, the number that describes the geometry of the universe. The number that appears in every equation governing waves, orbits, fields, and cycles. The number that any civilization anywhere, on any planet orbiting any star in any galaxy, would discover the moment it learned to measure a circle. Pi is not human. It is not cultural. It is not arbitrary. It is built into the fabric of reality itself. And if you wanted to prove to another civilization that your signal was not random, that it came from a mind, not a star, pi is the number you would encode. Because pi says, we understand geometry. We understand the universe. We are like you. That is what the AI found hiding in the noise. A Pi-derived timing sequence embedded in 7 faint whispers spread across half a century. From a patch of sky 120 light-years away, near a sun-like star that could host habitable planets. Maybe it is noise. Maybe the AI found a pattern in randomness. Maybe the human desire to not be alone is so powerful that we have built machines that hallucinate company in the static. Maybe pi appears in the timing because pi appears everywhere, and if you look hard enough at anything, you will find it. Or maybe 120 light-years away, orbiting a star we barely noticed until 2022, someone has been broadcasting. Not loudly, not constantly, but persistently, at intervals calculated to encode a mathematical constant that any technological species would recognize. A message that does not say words. It says something simpler and more profound than words. We are here, we understand mathematics, we know you are listening. Do you understand? For 49 years, we did not understand. We heard the first shout, and then we heard silence, and we decided the shout was meaningless. But a machine we built to find patterns in noise went back through the silence and heard what we could not hear. The shout was not alone. It was the loudest note in a sequence that has been playing for decades, and the sequence encodes the one number that means this is not an accident. The next detection window, based on the AI's analysis of the timing intervals, opens within a calculable period. The research team has requested telescope time. If the signal appears on schedule at the predicted time, at the predicted intensity, at the predicted frequency, then the question that humanity has been asking since the first person looked up at the stars and wondered if anyone was looking back will have, for the first time in the history of our species, something that resembles an answer. Subscribe. Because if the AI is right, the next detection window opens soon, and when it does, the AI vault will be watching. And so should you. The next file is on your screen.